Joint variation. In joint variation, one quantity varies directly. I mean directly as two quantities. That's all. Then if we have z relating directly to both x and y, we write z varies jointly as x and y. So this implies that z is equal to k times xy, where k is the constant of proportionality or the constant of variation. An example is how the area of a rectangle relates directly to the length and width of the rectangle. Partial variation. In partial variation, there is a phase constant in addition to the constant of proportionality. So the equation is of the form y equal mx plus c, where c is a fixed constant, or this c could be the fixed price of an item or the fixed cost, that is the initial cost needed to start up a business. Then this is the constant of variation. So the graph of a partial variation is of the form where c is the fixed cost or c is the fixed constant. T varies jointly as s and u when s equal 2, u equal 3, and t equal 30. Find t when s equal 4 and u equal 6. So this is a joint variation. So t varies jointly as s and u. So we introduce our constant of proportionality. T is equal to k times su. Now we sub in these values. So t is equal to 30 is equal to k, which is times s. S is 4 and u is s is 2, s is 2 and u is 3. So we obtain 30 is equal to 6k. Therefore k is equal to 5. So we sub in into this relation to obtain t. We sub into this relation. So t is equal to 5 times su. So when s equal 4 and u equal 6, we are going to obtain t to be equal to 5 times 4 times 6, and this is equal to 120. If x is jointly proportional to the cube of y and the fourth power of z, in what ratio is x increased or decreased when y is halved and z is doubled? Y is halved and z is doubled. So let's establish some relation over here. We have x being jointly proportional to the cube of y and the fourth power of z. So let's introduce a constant. So we get x equal a constant k times y cube then times z to the power to the exponent of 4. So now we're told that y is halved and z is doubled. So the relation now becomes k times half y cube then twice z cube to the fourth exponent, to the fourth exponent. So we simplify this, so we get x equal k times y to the power to the exponent of 3 over 8, or the same as 1 over 8 times 16. Then we have y exponent 3 times z exponent 4. Now we obtain x to be equal to, now 16 over 8 will give us 2 over 1. Then we are going to obtain times the same quantity, which is y cubed z to the fourth power. So you realize that we are multiplying by 2 and dividing by 1, so the whole thing will increase because the numerator is greater. So it is like 2:1. So 2:1 times whatever is there, because the numerator is greater, is going to increase. So we have y cubed z to the fourth exponent. Now we have x varies jointly as twice y cubed z the fourth power. Y varies partly as the square of x and partly as the inverse of the square root of x. So we are going to write the expression for y if y equal 2 when x equal 1, and y equal 6 when x equal 4. So we have this partial variation. We have y equal kx squared plus c over root of x. So we have two constants over here. So we just sub in the values and form simultaneous equations and solve. So we have 2 times k into 1 squared plus c over root of 1. So simplify this to obtain 2 equal k plus c. So let's call this equation 1. Now the next thing we do is to sub in the second set of values. So 6 is equal to k times 4 squared plus c over root of 4. So this will give us 6 equals 16k plus c over 2. So we multiply through to obtain 12 equal 32k plus c. Now we solve equation 2 and equation 1 simultaneously. So let me make c the subject here. C is equal to 2 minus k. So this implies that we have 12 equal 32k plus 2 minus k. So this will give us 33k. Now is 33k. We have 32 minus k, so you get 31k. 31k equal 10. So k is equal to 10 over 31. Now c will be equal to 2 minus 10 over 31. And when we simplify this, we are going to obtain 52 over 31. So we just sub in these values into the relation y equal then 10x squared over 31 plus 52 over 31 root x. So the correct answer is A. In a restaurant, the cost of providing a particular type of food is partly constant and partially inversely proportional to the number of people. If the cost per head for 100 people is 30k and the cost for 40 people is 60k, find the cost for 50 people. So we have this. We have the relation c equal k plus c over n. So this implies that our cn equal kn plus, let me call this k1, k2 and k1. So we have k1 plus k2 over here to differentiate between the c and the. So we have for 100 people 30k. So the cost is 30. So the c is 30 and the number of people is 100 equal the 100 times k1 plus k2. Then we also have for, so if we simplify this, we get 3000 equal 100 k1 plus k2. Then we also have for 40 people. For 40 people, we have 60. The cost is 60, so we have 60 by 40 equal 40 times k1 plus k2. When we simplify this, we obtain 2400 equal 40 k1 plus k2. So solving equation 2 and equation 1, we obtain negative 60 k1 is equal to negative 600. So k1 is equal to 10. So this implies that our k2 is equal to 3000 minus 100 times 10, and that will give us 2000. So we have our C equal 10 plus 2000 over n. So substituting the 50 into it, we have 10 plus 2000 over 50, and this will be equal to 50k.